Hello, everyone. I'm Arief, and I'm joined with Mr. Gresaf. And today we are going to present about our case study of using the Lean Transformation Network in mining, specifically in increasing the availability of spare digger buckets. So much like our colleagues in the main stage before, who presented their use of LTF in the nickel production, we use the same framework to do an improvement in the mining sector in the company, specifically in how we can we can prepare the spare bucket on time. So first, maybe a little bit of the background for it, Mr. Gresa.
Yeah, thank you, Mr. Arief. So why we choose this topic? Because our mining area is very unique, yeah, because there are many hard rock in our mining that mix with soil or with nickel. So it make our bucket lifetime short or easy to run out. So as part of the maintenance division for a sizable mining operation, the value that we bring to the table is how we keep the equipment running. As equipment running in their best condition means operation can also function at their best. Some of the most important equipment in our operation are digger, yeah, that are responsible for all the mining. Except it is a high priority to keep them going much as possible. We have faced the problem too. Many our digger face lengthy downtime. Yeah, many of them revolve around the bucket use those digger as a component that face a lot of wear. That is unexpected, which is why it is important for spare bucket and are ready to replace ones that are in bad condition. This was where the big problem existed. We didn't have enough spare bucket that we ready. Then because there weren't ready many of our active diggers, we forced to continue while being overdue for replacement, which led to more problem in long run. The problem was that the majority of the spare bucket that we had were waiting to be repaired. As to keep supply going, we have to repair used bucket as the spare for the next replacement. Otherwise, our option will be to purchase new ones and will require much more additional capital. However, the repair process cannot keep up with the demand on the field, resulting in the large backlog of bucket to be repaired. There is a problem in our process that is damaging our value stream. So it must be found and must be fixed. So if we see the box in red box, the spare of bucket is in storage about 60%. Bucket for repair or in progress repair. Actually, normally the spare bucket in storage is 0%, yeah, because we want to all bucket ready to use that, and when the digger need bucket to be replaced, the bucket was ready to install in the unit. Okay.
Okay, I'll continue on. So now we know that there is a problem in our value stream. So we have to re-examine our process to see where the problem actually lies. In essence, to simplify the process, when a bucket from the field is replaced with a new one, it is then the old one will be placed in the maintenance backlog waiting for repair. When the shop has an opening to do a repair in their work cell, that a bucket is then sent to the shop. After it reached the shop, the scheduler of the shop would then do the administrative process and purchase materials for it. When everything is done, can the mechanic start the repair process, and after that repair is done, the bucket is returned back to the maintenance storage ready for use. Now, from this process, we expanded our understanding by creating a VSM of it. In essence, what we learned from doing this VSM is that we have the takt time. We know how many buckets are needed in a year. We needed a bucket to come out with a cycle time of 6 days. But when we look at the process, especially the process that happens in the shop, we see that the actual cycle time of the current process is 8 days. So we have a mismatch between the actual cycle time and our required takt time. This explains why we had problem with not enough spare buckets. Now, by wait, one moment. By doing this VSM, we managed to pinpoint the other problems that causes this issue. We see here that the administrative process that is done while the bucket is in the work cell is essentially non-value adding process that is taking availability of the shop work cell away, because while this is all happening, the bucket is just sitting there in the shop, not doing anything, and frankly just wasting everybody's time. Aside from that, we also identify that because of that, we have a large inventory of bucket in the backlog, because most likely in the past, to deal with the problem of not having the bucket ready in time, it was decided that they would just add more buckets. But in the end, this doesn't solve the problem. This just push it further away. So during this process review, we see our current state and our target state. And from here, we know that we have a two-day deficit. Now, how do we solve this? One solution is to just increase the capacity of the shop. But of course, that would be more capital investment and would be more complicated due to the limited area of the shop. But through our identification of the weak spot, we can change the process so that we can achieve our target state. And this is what we've managed to make as a result of our identification. As we had previously identified, the administrative process is a non-value adding process. So we remove that process from the shop cycle time. To do that, we essentially complete all of this administrative process loop before the bucket is delivered to the shop. To do that, we have a change in where the trigger for the process begins. As before, this notification only happens when the bucket reaches the shop. But now, when a bucket is in progress and it's reached 80% of the work, or when the welding repair is done, the mechanic will send a Kanban signal to the scheduler to start the notification process of the next bucket in line to be repaired. Of course, this also requires the parts coordinator who holds the buckets in storage to send out to the scheduler their priority list, which bucket should be worked on next. And this is the essence of it. We've managed to make reduce the cycle time by removing this non-value adding time. But for this new process to work, we need changes to happen with the people involved in it. So the mechanic, the scheduler, and the parts coordinator, there needs to be a clear horizontal information flow between them. The mechanic needs to accurately tell the scheduler when the estimated time of completion for the work in progress. The scheduler needs to tell the parts coordinator when the expected results based on the mechanic is, and the parts coordinator needs to tell the scheduler which bucket should be worked on next, so that they can finish this non-value adding time process in advance. So this is the importance of knowing the process and clear horizontal communication between the parties involved. So after we've managed to develop this new process and develop the people horizontally for the frontline workers, we need to also look at how the management factors in. So, Mr. Gresaf.
Okay. Yeah. With a solution in hand, we next need to foster the management environment that we will help us to not fall back to the previous condition. And to do that, we first had to look back and how the problem reached this point. From the open discussion we conduct with management and frontline worker, we found that there was a gap in how they saw what was happening. With the excess of inventory spare that was available, management couldn't see the problem forming. Seeing that the process is still functional the same, they were under the benefit that things were fine and still had control, but noticing the amount backlog steadily increased. Only when it reached a critical point did the problem became apparent. The frontline workers, on the other hand, felt that problem building as the slowly fell more pressure horizontally as they have a more constant view of the building backlog. However, they were focused on making sure that their production targets are fulfilled rather than rocking the boat. By maintaining the existing condition, the growing problem was overlooked. This highlight the importance of vertical communication to make sure everyone can contribute to a full picture on the actual condition. And why it's important for the management system to be able to foster an environment that want to improve continuously. In doing so, creating a habit of constantly looking at the process and how to improve it rather than being satisfied with the current condition.
Right. So in essence, what's important is during this case study and this project is that we've managed to implant a new basic thinking for the people involved here. In essence, this project shows the importance of understanding what value we need to deliver to the customer and also where it exists in the process. We see that by just adding more components to the process, it doesn't solve the problem. It only kicks it down the road. This is because the amount of spare component was never the problem with the value, but it was in the process itself. It was in how fast can we ready a bucket again. By correctly identifying where the real problem is, could we see the real problem and we can remedy it so it doesn't happen again in the future. By continuing this line of our thinking in our future review and improvements, we hope we could achieve more lasting changes and effective changes that actually matter to our end goal, which is a better operation for the equipments, and of course, a better results from the operational team that uses our equipment. So that was a bit of a summary of this case study. Maybe we can open it for question if anybody in the audience wants to ask some questions.
Yeah. Okay. Hello, Mas Arief.
Yeah.
Okay. Okay. Thank you for your explanation for that case study. Maybe for the Q&A, yeah, there is some question. The first is how about the challenges for implementation this lean transformation framework in mining?
Okay, so let me go back a sec. So one of our key challenges was how can we change the process and change the mindset of the people, and also gain the support of the management. As we saw that there was a gap between the management and the frontline workers. So there was a clash in how, when we wanted to try to change this process, when we try to take out this non-value adding process, because at that point, as we previously mentioned, the workers was still working to complete their target. And changing this paradigm, this change of paradigm of how they conducted the work felt like they were almost not delivering on their target. So, for example, we have to make the notification at the start before a product is even at the shop. That means that the total work in progress that's in their system would be increasing compared to before. And because this was a KPI for them, they were reluctant to do that. It was only after we managed to give an aligned vision to the management, to give the frontline workers permission to do this, were they more comfortable in doing this differently. So again, this is why it was important to align the vision between the top and the bottom, because even though the workforce itself saw the problem, knew how to fix it, but because they're afraid of the restriction by the company, they just stood still. And that's a challenge of itself, to change the mindset of the people involved and also the management.
Okay. Maybe I will continue the question from your explanation. You said the obstacle is the mindset from the operator, right? How long you can change the mindset from the operators, from the old mindset to the new mindset that you have already implement this improvement? And then for now, how about their feeling about this improvement?
So even now, it's actually still a work in progress, because
Okay.
yes, they've changed their mindset, they're accepted this, but it's not like they can immediately change how they work instantly. It's still an ongoing process, but with the help of the management, it's been going for a month or two right now, I think. So it's still a developing thing, and we hopefully, like we said before, it's a basic thinking thing. We hope this is something that will continue to grow with them. And it's not just because it's not just for this. What we cover here is for the excavator buckets, but this problem also exists for the other equipments, right, Mr. Gresaf?
Yeah, so there are same problem with other equipment. Yeah, the same problem. For example, for dozer and loader, if the repair of bucket delay, so the equipment will increase the downtime. And for I just give addition from Mr. Arief that how we change the mindset of the employee or the workers. So we socialize the worker that to increase the sense of ownership, because this company is ours. So if this company get a high profit, it will affect it to our prosperity too. So hopefully if we can give their understanding to the worker that they have to increase their ownership, they will have motivation to solve this problem, to repair this bucket fastly, and then our bucket spare will available and ready to use whenever we need to install to the unit. I think that's for me.
Okay, thank you. Maybe for the last question, for both of you. What is the next action for this improvement? You say this is still in progress, right? So what is the next action, or maybe you have some planning of that?
So let's see. So one of the still in progress action is that one of the cause of the cycle time is a delay in transport as well. This is still in progress because this also involves another party, which is the rigging team and the transport team. So that's also in progress. How can we remove this delay as much as possible to reduce the cycle time? And as Mr. Gresaf mentioned, this is a recurring problem not only for the diggers, but also other equipment such as the loaders and the dozers. This is a problem that those equipment also face. So the next step is actually also copying this improvement to those equipment as well, to the different ones. But those one actually provides a further challenge, because while we were a bit lucky with this digger bucket, because from what we see of the current cycle time and the target takt time, we were still able to achieve that target takt time just by removing this non-value adding process. From what we've done with the other equipments, that actually wasn't enough for them. So for those ones, we do need more capacity, but by copying this improvement, the additional capacity that we need to invest in has decreased. So from, for example, for loader and dozer, when we first calculated it, we need an additional 6 working bays, but after calculating the gains we get from copying this improvement, we've managed to reduce it to 3 additional bays. So we still found value in them, but unfortunately, it doesn't stop it from when the capacity is just way too much over the line. We still need investment, but we can minimize it to gain value from it.
Okay, awesome. Yeah, your improvement is very interesting, Mr. Arief and Mr. Gresaf. Hopefully, the improvement you say can copy in another equipment. Yeah. Okay.
Yes, that's why again the important thing is how we implement this basic thinking for all the peoples involved in the maintenance division from the shop.
Hopefully. Okay, maybe that's all for our presentation. Thank you for your attention. And Mr. Arief and Mr. Gresaf, thank you for your explanation. Okay. Maybe you can leave this webinar. Thank you all.
Thank you.
Thank you.